Every piece of software evolves with time, marked not by sessions or years, but by version numbers. They tell a story of progress, of fixes and features, of the past and the future. Today, we will explore how to compare two version numbers, a simple yet powerful task in understanding growth and change. In this problem, we are given two version strings, version 1 and version 2. Each version string is made up of revisions, which are separated by dots. The challenge is to compare these revisions in a left to right manner. There are two important rules here. If a version has missing revisions, we treat them as 0, and if a revision has leading zeros, those are ignored. So for example, 1.01 and 1.001 are actually the same since both represent revision number 1. Based on the comparison, we need to return one of three possible values. If version 1 is less than version 2, we return negative 1. If version 1 is greater than version 2, we return positive 1. And if both are equal, we return 0. So the function is essentially behaving like a comparator. Let's go through the first example. If version 1 is 1.2 and version 2 is 1.10, we first compare the first revisions, which are both equal to 1. Since they match, we move to the second revision. Here we see that 2 is less than 10. Therefore, version 1 is considered smaller and we return -1. In the second example, version 1 is 1.01 and version 2 is 1.001. When we ignore leading zeros, both 0.1 and 001 become the number 1. So the first revisions are equal, and since there are no more differences, the two versions are considered the same. The function will return 0 in this case. In the third example, version 1 is 1.0 and version 2 is 1.0.0.0. Here version 1 has 2 revisions but version 2 has 4. However, the missing revisions in version 1 are treated as 0. That means we are essentially comparing 1.0.0 with 1.0.0. Both are equal, so the output is 0. Now let's discuss the solution idea. The problem can be solved by splitting the version strings into their individual revisions. We then compare each revision as an integer, which automatically takes care of leading zeros. If one version has fewer revisions, we pad it with zeros to ensure both versions are aligned. Finally, the result is decided based on the first mismatch we find. If all revisions match, the versions are equal. Here is the Python solution. We first split both version strings using the dot separator and convert them into integers. Then we iterate over the longest length of both lists. If one list runs out of revisions, we use 0 as a placeholder. During the comparison, if we find a smaller revision, we return -1. If we find a larger revision, we return +1. If we complete the loop without finding differences, we return 0. This approach is clean and very readable. Now let's look at the optimized C++ solution. Instead of splitting the strings into arrays, we parse each revision on the fly using two pointers. We extract the next revision number by reading characters until we hit a dot or the end of the string. We do this for both version strings simultaneously. If the two revision numbers differ, we immediately return the result. If they are equal, we skip the dot and continue. In the end, if no differences are found, we return 0. This avoids extra memory usage and is highly efficient. Let's analyze the complexity. Both solutions scan through each character of the version strings at most once, so the time complexity is linear in the length of the strings, or big O of max of n1 and n2. In terms of space, the Python approach requires extra space because of the split lists. The C++ optimized approach, however, does the parsing on the fly, so it only uses constant extra space. Here are the key takeaways. First, always handle leading zeros properly by converting revisions to integers. Second, remember to pad missing revisions with zeros so that comparisons are fair. And third, the best approach is to compare revision by revision instead of trying to compare the entire strings directly. This concludes the explanation for the problem, compare version numbers. Thank you for your attention.